In this lesson, we're going to cover what makes a blockchain decentralized or distributed, and we'll look at the different types of networks that we have available to us. So first of all, we're going to just cover quickly what are peer-to-peer networks. Then we'll look at the different network models that we have available. We'll look at distributed blockchain. And then we'll ask the question, is Ethereum decentralized or is it distributed? We'll look at some of the problems surrounding centralization and centralized systems. We'll look at the benefits of decentralization. And then we'll go through a demo, which we'll continue with our demo on the blockchain. So let's get started. Distributed peer-to-peer networks. So a peer-to-peer network is a network of computers that allows information to be shared across the users. So this essentially allows users to send information directly to one another. So in this model, there's no need to go through any central authority or centralized server. This gives a way for users to connect directly to each other and share information with each other. This allows this open communication, which is directly between different nodes. So what are the different network models that we have available? We have centralized, we have decentralized, and we have distributed. Let's take a look at each one of these quickly now. So in a centralized model, you might depict it something like this, with a central node here in the middle, and then all of these client nodes connecting into the same central authority. So an example of this might be a library. This is a good analogy to use. Imagine you live in a big city and there's one big central library available in that city. Now, if the library is destroyed, and all the information is then lost because it's a central data store. So this is a problem. This is a single point of failure. The other challenge with centralized networks is speed. No matter where you are in the network, you have to travel to this central point in order to fetch your library books. So even if you're far out in this node here or this node here, you have to travel way into town to get access to your library. This is the same with computer networks, where the distance traveled affects the latency or the speed at which you can fetch data. And of course, a centralized network or a centralized application has a single point of failure and of course a central point of control. More on that later, but let's look at the next network type, which is decentralized. Now, a decentralized network is where we are able to copy the library into several locations around the city. So here in this diagram, we can see a sort of a collection of mini networks, if you like. There's a library here with these peers or these nodes connecting to it. There's a library here, and so on. And so if one of these libraries should be destroyed, then it's not the end of the world, because the library can then be replicated again and copied over to rebuild the node that was destroyed. Moreover, speed is now improved because there is a greater chance of there being a library or a node near to where you are. So that's a decentralized network. Now, a distributed network takes this to the extreme. This is how a decentralized network looks. And what this means is that everyone in the network becomes the library. In other words, every single node on this network now has a copy of the data, a full copy of the data, or a full copy of our library in the library analogy. So since everyone has access to the information, this information is literally at your doorstep. And in this case, if the information is destroyed, then you just simply would resync with your nearest neighbor. And given that it's a distributed network, this means that your nearest neighbor is going to be pretty nearby, especially if the network is very popular. And finally, speed issues are completely removed because you own the library, so you own the data. So this is a distributed network model. So this begs the question, is Ethereum decentralized or distributed? Because you may have been reading about Ethereum and blockchain, and most of the time you probably hear it being referred to as being decentralized. So let's take a quick dive into this topic. So it is possible for Ethereum to be fully distributed. That's because of the way that the Ethereum node and the Ethereum network has been designed. But in practice, it's not being used as a fully distributed network. Why is this? Well, this is because many users on the network choose to connect to third-party node providers, those being Infura, Alchemy, BlockCypher, and many others, rather than running their own local node. And so, given that many users on the network choose to connect to a store such as Infura or Alchemy rather than running their own node, this yields more of a decentralized system rather than a distributed system. It means that essentially Infura and Alchemy and BlockCypher and others become these hubs which many people and other nodes will connect to fetch their data and rely on. So we'll continue with this topic on whether or not Ethereum is decentralized or distributed. So it's up to the user, that's you, of the network, if you want to run your own node, that's your own Ethereum node, and be part of a more distributed system. If you want to do that, then you can. And of course, if everyone did that, then it would be truly distributed, but that's not the case. Now, running your own node and connecting your own wallet and dApps to your own private node is more secure, trustworthy, and reliable than using any third party. However, running your own node is obviously going to be more technically challenging and time consuming. So unfortunately, you can't have everything. Now, throughout this course and on most sources on the internet, you're likely going to be hearing about blockchain being referred to as a decentralized network rather than a distributed network. Moreover, most of the exercises and tutorials that you'll come across, including the ones in this tutorial and lesson here, will be connecting to third parties such as Infura and Alchemy and BlockCypher, as mentioned earlier. Even when you go into the industry and start working for different companies, a lot of the startups, a lot of the projects will connect to one of these node providers. But you might see some bigger companies or more established companies, perhaps some exchanges, who have chosen to run their own nodes for the same reasons as mentioned here, for the security, trustworthiness, and reliability. So, the Ethereum network. We can take a look at the Ethereum network by taking a quick look at this map. Now, this map I copied from this source here, etherscan/node tracker. And if you take a look at this, you can see there is a heavy weighting of concentration of nodes in the United States and Canada, as well as Western Europe, the UK and Germany in particular, as well as a few in Australia. And then the rest are sort of distributed across the world in small numbers. Now we can take a look at this site. I've opened it up already here. We get more information on the actual site itself. This is the map that I copied earlier. So you can see it's a sort of heat map of concentration of nodes, and it's broken down into this table here. You can see that United States has the most number of nodes running at about 34%, followed by Germany and the UK, and so on and so forth. So take a look at that for some more information about the nodes that are running in the Ethereum network. There's also another site that you can check out called ethernodes.org. This gives you a bit more different statistics, in particular the different types of nodes that are running, so the providers of the node. So this is Geth. Geth is the most popular, running at about 82% of the network is using Geth. And then Open Ethereum and eRegion and so on and so on. So there's all these different node types that are running, but Geth is the most popular. So take a look at that for some more information on that. And there's the link there to that site. What are the problems and challenges with the centralized system? Well, a centralized system has its issues, and it's basically an environment where a single actor or actors can end up exerting full control over the functioning of the network and also all of the development decisions that are made in this network. So if we apply that to a centralized blockchain, this is one that could essentially be very easily taken over and controlled by governments and corporations. and where its functionality and development are unilaterally controlled by its core creators and its core developers. So what this leads to is a risk of full control and governance by a central authority, and it could end up changing who originally developed the platform. So it could originally be created by someone or a group of people that maybe you trust and admire, but then down the road it's taken over by a corporation or an organization that you don't particularly trust or want to be associated with. And these are the main problems of centralization and why we need to look at alternative approaches such as decentralization. So what are the benefits of decentralization? Well, we end up with a trustless network community. We improve data reconciliation. We improve transparency and openness. And we also improve resource distribution. So let's take a look at these one at a time. So decentralization benefits, first of all, trustless network community. So the users of a decentralized blockchain network do not need to know or trust anyone else on the network. Well, how is this? Well, this is mainly because every user or node on the network has an exact copy of the blockchain database or the distributed ledger. And so if anyone's ledger is altered or corrupted in any way, it's immediately rejected by the majority of the other nodes on the network. So thereby, with this property, we are able to trust the data because it's sent to us and validated by our own private node in real time. And remember, the validation is done through the hashing mechanism that we saw earlier. So the next decentralized benefit is that it improves data reconciliation. So companies naturally will exchange data between business partners. And when this happens, usually when the data arrives, the data is manipulated and transformed before being stored in each of the organization's private data silos. And what this has an effect is it may cause unwanted data loss or incorrect data to be stored in these data silos. There could be a problem with the transformation function. There could be a problem with manipulating the data, maybe even on purpose, to change the numbers, to change values, and so on and so forth. So with a decentralized data store, such as a distributed ledger blockchain, now every organization on the network has access to the real-time shared view of the data. And this gives you a source of truth that everyone agrees on by the very virtue of the validation mechanism provided by the blockchain. And the other benefit is that it improves transparency and openness. So decentralization helps to foster transparency and openness. And this is due to the fact that the data is shared in real time across the network to all the peers and is immediately validated by all of these peers. So again, this builds on the fact that the data is automatically distributed across the network and it is validated in the network so that you can be sure that it is a true source and an untampered data set. The final benefit is improved resource distribution. So decentralization can also help to optimize the distribution of resources. So if an organization promises services, then these can be then provided with better performance and consistency with all the involved parties. This is mainly due to the fact that everyone in the organization and in the network can be sure that the data they are working with is the valid, trusted source of data. All right. Next up, we're going to continue with our blockchain demo, where we'll look at a peer-to-peer version of the blockchain and essentially try this out as a distributed ledger and see how this works in practice with this demo. So I'll see you there.